All right. Hello, everybody.
Hey, Jean, how are you?
All right. So, pretty good, pretty good. How is it doing the computer science project? Did we get started?
I am 95% of the way through. I did a little bit of embellishment, and also I'm not using any of the hardware that y'all are. I'm using a Raspberry Pi, and an LCD screen and some potentiometers, a DHT sensor, and some LEDs. And I might even throw in a speaker, just for giggles.
Cool.
Yeah.
And that is something that like that I've added on with my students and stuff before. And those who do have one, an LCD screen is a great one to be able to add in. During one of our Astro camps, I believe it was last year, one of my students who had just finished up Principles of Engineering wanted to take it a little bit further and incorporate the thermostat into what we did with the students at Astro Camp. And so he did up diagrams and a little booklet to help them get started with the program. But yeah, he added a buzzer to it so that with the thought that, if the pressure, if the temperature changed, that I wouldn't just be able to kick on and stuff like that too, but taking it a little bit further, that say the astronauts were sleeping, they would need something to help wake them up. And so a cool embellishment. But I can't wait to see what you guys have on that part. Anyone else with something to share for what we've been working on? Oh, that bell. All right. I'll go on ahead and share my screen then. All right, and our sign-in word for today will be myoware. We're going to be talking a lot about the myoware sensor today. myoware. All right, so we're going to switch over to the biomedical unit. Typically, as you see here, it says Unit 9. This is typically the last unit, or this unit is recommended for most to be the last one that is taught, because it is the more complex project for most that they'll be working on. All right, and it really, with that too, kind of depends on how you approach the project. This one is a lot of fun. The students tend to get a whole lot out of it. I was actually reflecting yesterday after I got done with you guys. I had some students who were here, and we were talking about how a lot of these projects in Principles of Engineering how they branch out into other projects later on that I know my students have really gotten into. So with biomedical engineering and that interest, and we're now working on an actual biomedical project for a 5.5-year-old girl who has spinal muscular atrophy. So that's kind of one caveat, and you'll see here when we get talking about the within the background information that's presented in the slide deck, you can kind of see real quickly where it would pique students' interest to be able to make some of those turns. With the thermostat project, that's one that, as I had mentioned earlier, I had students who decided to take that project and adapt it to be able to use for an astro camp that we did during the summer last year. Also had students in my engineering design class this past year for their final project. They decided that they really wanted to create a device that would be a gauge at the end of somebody's faucet, to where you would have a temperature sensor included in that, of course, one that could handle water or design that way, and then would feed back and be able to give both an LCD reading of the temperature, but then also to do it according to lights that they had light up, whether or not it was too hot, too cold, or just the right temperature. And they base that off of temperatures that certain people might need to have, like especially for giving baths to infants and stuff like that as well. So it's neat to see how these projects, because they are quite memorable for the students as they're working with them, how they continue to transition that way. All right. So I have what you see open for you right now. The reason I switched the order and have biomedical engineering is how we're ending the week is because this is a bigger of the projects. So for this teacher training, you only have 2 projects left. This one today in getting your MyAware sensor to take a reading and interact with a claw. And then you have one more next week for environmental engineering. Okay, but since the 2 Arduino projects, and that way I put them back to back with a weekend right after that to try to alleviate some of the time crunch. Okay, so I'm going to go on ahead and get us started. And reviewing over the slide deck. What I really learned how this course and the progression of courses has been developed as well. Maybe you've already noticed, I know I've mentioned very briefly when we did civil, is that between intro to engineering and principles of engineering, you'll see some of the projects build on one another. And so with biomedical engineering for intro, they're of course making a hand, a prosthetic hand in that way that out of cardboard, and they're focusing on either a pincer grip or a grasp, a power grip. All right, so either pincer or power. It's where they're either picking up something small like a pen, or in picking up something heavy. We get into that a lot with respect to some of those same discussions, because for this one, of course, they're making a prosthetic hand again, but now they're motorizing. Okay, and like with civil engineering, you go from a bridge they work on and then move, a bridge that they build, one of the 6 basic bridge designs, and then when we get here to civil, now we're taking those designs and we're adding movement to them with hydraulics. All right, so just as before, a big piece on this one, because I know as this doubles as a physical science credit, and now we're bringing in with this one a lot more with respect to biology. I know for myself, when I go through this net with my students, I spend a lot of time discussing the electrical side of biology in terms of how neurons move. And it is built in for us to be able to do that. But we spend a lot of time going back and forth talking about some of the chemistry behind some of that as well. And anyway, I just wanted to make a note of that, because especially too, when you're looking at some of your lesson plans and stuff that you do for this, I know because this is counted as a physical science credit, I know one of my supervisors and I, that's something that we've worked on, is to make sure that there is that carryover into this unit as well. All right, and so then we have our bell ringers that can be incorporated. And really the biggest thing for this is we're going to be working a lot more with sensors. And in terms of that kind of critical thinking or computational thinking, we're really focused with students on inputs and outputs, how signals are received, how are those processed, and then the execution of that process. Okay, but to start off, like we do every unit, we talk a little bit about the engineering field in and of itself. With respect to biomedical engineers, the big focus to take away for them is that this does have to do with the human body and what we are able to do to be able to make life easier for people as well. Okay. I will get asked this questions from time to time, like the difference between biological engineering and biomedical engineering, which in and of itself can classify as being exactly the same, of course. However, with biomedical, more the focus primarily on the person. Okay, so this, just like before, in bringing in with intro, you're going to go over the 4 basic fields with students. This always ends up being, for me, an extremely interesting discussion. As the only engineering teacher here at Hammond High, all of our IB students, international baccalaureate students who are going through the career pathway, once they become juniors, they have to come up with an ethical dilemma that they then spend the next year and a half focused on researching with their mentor. And then they write a reflective paper based on what they discover. A lot of times, biomedical engineering ends up being a huge focus. So I think over the years, biomedical engineering and software have been, and programming have been some of the most popular. This year, actually, I've had the most diversity. But with that, you're talking with them and bringing in so many cool different kind of cutting edge technology that's being done with all of this, all of these different fields right now. And I do appreciate the opportunity this gives to be able to talk with students and kind of push them to think about where limitations can be held. Actually, one of my students, one of my IB students was kind of inspired by a discussion we had during Principles of Engineering during our biomedical unit. And he took that further and kind of went a Marvel Universe route, and he kind of took it along the lines of with technology continuing with its improvements, and so much of what is being mapped in terms of how we've been able to find where those nerve endings and stuff for controls of different parts of the body lay out to, so where you can map things and just control it with your brain. And so I know he's done a lot of research with that. We've talked about that stuff in my class before, and he has taken it along the lines of where do these improvements in prosthetics, where is there a line potentially drawn, or shall it always remain gray, that one day we might not have the development of some type of bionic arm that is endowed with superhuman abilities, and what would be the parameters, or what could be some of the parameters that could be placed on that. And that's based on the notion of, well, what if you could take it as far as like athletes, professional athletes, that say you have someone who part of their skill is having to throw a ball, and they tear a lot of damage with respect to their shoulder and arm in general. Would it, or should it be allowed then that they're able to make improvements by replacing their arm with a prosthetic that the can control, and then be able to have a perfect throw with? And seeing that along the lines of how long would it take between something like that happening and you having people who can decide if they want to replace an arm, basically having a shop for body parts. And that's something that has been interesting in terms of getting to hear the perspective of my students and where they come from on some of that stuff, getting them thinking about that as well. So, but anybody who knows anything about the Marvel Universe could kind of see where this young man was coming from, is thinking about what if everybody could have an arm like the Winter Soldier. All right. And moving on, discussing this with the students. Now we're going to get into a very specific niche within biomedical engineering, and that is in working with prosthetics. And having them be able to talk through, of course, the purpose of a particular prosthetic, and in terms of trying to make it easier for a person to function within their environment. What types, or how is the hand going to actually interact with that, with respect to with that as well, of how much do you make the hand look like an actual hand, as opposed to something that is more functional rather than, in this respect, cosmetic and looking a little bit more as though a hand does. You also have to have those considerations in terms of the materials that this is being made out of. The hand in and of itself has so many different functions. What it is able to do, it helps us with communication. It helps us with picking things up, both small things or with a power grip. It is the way that we sense and feel and interact with the world around us. So there's a lot of different considerations. It is not just a simple project or simple thing to go through and try to create a prosthetic hand. And so then this gets to be a really great conversation to be able to have with the students on that part of what are going to be the constraints inherently when you are working to create something like this. There's actually a little bit further. We get to slide 9. There is an article embedded here for people to be able to share with their students if they wish, and just for some cool reading on your part if you wanted to add it and talk with your students about it. But it's about new material that's being developed. And of course, this is something that's happening all the time. This particular material, what it does is help to work with the longevity of the prosthetic. So it's a way that it's a material that's actually able to absorb pressure, some different electrical impulses and stuff like that. And so it can, in a sense, kind of heal itself, not heal itself in terms of, as someone would think, like laying on hands and stuff like that, but it's a more forgiving material and stuff like that being used. And that article is embedded here because your next set of slides is going through the history of prosthetics and just the functionality of them. One thing I do always, sorry, I'll bring it right here. One thing I do always tend to note with my students as I go through is the fact that typically with each war, especially those in modern time, you tend to see the most advancement or significant advancements being able to be made with respect to prosthetics, because that's an unfortunate offshoot. Getting back to, another example of this has to do with things like plastic surgery, of course, which plastic surgery is something that really finds its origin or root in terms of how it is utilized today, or how it's thought of today, back during World War I in response to the disfiguration that soldiers experienced due to chemical warfare that was now being introduced. And so you had some French surgeons who, in response to what they saw and how they wanted to improve the life of these soldiers that they were working with, life of just common other people, because it was, of course, the damage was widespread. They came about procedures to be able to do that with plastic surgery. And, you know, you can easily take here with plastic surgery, if that's at its root, is working to fix these disfigurations. And of course, there's been amazing things done with plastic surgery to be able to help people with their appearance when it comes to things like cleft palates and not just their appearance, but also their ability to speak and more clearly and how they're able to eat and do things like that. But anyway, in taking care of some of those deformities, and then you can take it further in the fact that, you know, now we can just elect, I don't really like my nose. I think I kind of want to change, the fact that bridge I have on my nose right there that shows I have some pretty strong Sicilian root. I can go in and change that. Maybe I don't like the way my ears stick out, particularly from my head. And that way I want to pin them back or not have them so close possibly to my head. So it's a way of, here's something that was made and has become more commonplace. And so these do get to be really cool conversations. It really, of course, depends on your interests as well. So from that history, now we're looking at information with respect to how we control prosthetics. And of course, initially, in earlier, well, actually, it was here earlier days with external cables and switch control systems. Prior to that, it was just this static attachment that the way it interacted is you had to move the rest of your body, right? But now what we're talking about is bringing in different electrical systems, and of course with different sensors and electrodes and stuff like that, that we're able to show and develop greater control, more seamless control for the person who is utilizing it. There's this great video I actually show my students of, it's in the Google slide deck or site that I developed for this unit for my students. It's of a woman who happened to, she went out into her backyard and unfortunately found that her small dog was being attacked by a raccoon. And that raccoon, she wasn't thinking and she ran to protect her dog, pulled the dog back out. She herself ended up scratched and bitten by the raccoon. And of course, the raccoon ended up having rabies. And she lost actually the majority of her arm as a result of trying to keep the infection from spreading, the rabies infection and spreading to the rest of her body. And what it is this woman then comes in and you see her years later, she's working with a group of engineers to, it was her first setting to be able to sit down and utilize an arm that she has, actually in the video, the arm is out in front of her, but she's controlling the arm entirely with her brain. And it was really neat in the video to be able to hear her perspective of that and to be able to see those initial moments, because I guess amazing out body experience that would be. On that, we're able to take what she did have left of her arm was just a little bit at the shoulder, and they were able to map out actually from that point the nerves that control the entire rest of her arm, different functions, her fingers, those that would move in progression to like make her elbow bend or her wrist turn. It was really cool to watch that process, to be able to see that part. And then from there, this entire prosthetic was being built. All right. So, yeah, this is usually in front. Okay. So for this one, that we want to hit home with the students, and you will see this definitely pops up on the quiz, and it does in the homework section, is that tenet that there are three principal functions when it comes to the nervous system. You have sensory input in that respect, the integration that's found, and how that sensory input, that electric impulse is processed by our brain, and then the motor output. And when we bring this up, we discuss things like, I'll have my cup that's out in front of me, or I might have my water bottle with me, and discuss with them the process that it would take in our nervous system, utilizing these three principal functions for me to pick up my cup. I would need that sensory function of just being able to have an awareness of where the cup is. Those impulses, which detail a vision of what that cup is, are then sent back and processed or integrated, so to speak, in my brain. And then the impulse that is then developed into a motor output, right, through the use of my arm. And as that's happening, there's that constant back and forth of what we are doing, that I'm constantly able to use my sensory input in order to refine the movement of my muscles to pick up that cup. So here we take them through this portion right here again, and you can take it in terms of being able to walk or kick a ball. Your brain is what is going to process, and then talk about how it's using that motor neuron to be able to take and then bring back the send to control your leg. Or it could be that there's a tickle in your leg or something like that. So it's sending that information and stuff through your motor neurons again, or through the neurons again, and back to your brain. I do really love this picture with respect to the neuron that's pictured because of the great display of the myelin sheath coming through here and that way, and talking to students about what is something that we learned with respect to electrical work when we were working with wires and electrical engineering. You can have conductive wire, but in order to make sure that the electricity gets where you want it to go and doesn't short circuit somewhere else into the environment or dissipate out to where it doesn't get to that point, you have to have some type of insulation around it. And that is what that myelin sheath acts through there. And of course, these are like little nodes in here that can help amp or juice up the electron, the impulse as it goes through, especially in terms of how long certain neurons are that run through our body. Most are not very short at all for the motor neurons. This gets into a really great conversation and stuff like that as well, especially if you have a lot of students in your class that potentially have ADHD. So here in the anatomy of a neuron, we talk about the fact that you actually have dendrites on two different sides, okay? So here, typically, I'll have that, what I start in talking about is my soma. So that's the cell body, which is working to integrate on a very basic level the neurochemicals that are brought in, so signal, if you will, through your dendrites. And so neurochemicals are brought in through the dendrites. The dendrites in that way, those neurochemicals serve to change up the electrical potential of your neuron. Okay, so in certain entities in the way that a neuron needs to be fired, or the electrical impulse needs to be fired, it goes down the axon here. The axon is actually what's underneath these little brown globules right here. Those little brown pieces, then of course being your myelin sheath. All right, and here at the end, you have dendrites, again, that are going to release their neurochemicals. And if you picture here, you would have another neuron right here. And you can go even further, and some students know that as well with those junctions. And we will actually on the next slide. Part of what's happening right here is you have chemical changes that are occurring because of that electrical impulse as it travels down. So you can get very complex talking with the students about this. Really depends on your interest and of course theirs as well. So this is a depiction here. That's taking apparently with somas that have faces. It looks like a brain sucker now. So now it's taken, and those dendrites now at the end of the nerve cell. You can see here in a blown up version, those are those neurochemicals that are coming through. They get released into this right here area, and that's, whoops, I forget, I have control these. That area is the synapse, and this portion right here, this darker purple portion right here, are actually the dendrites of the next neuron underneath. So those get absorbed across the cell barrier, and then the whole process starts all over again with those neurochemicals changing the electrical potential of the next cell, that being processed within the soma, that cell body, and then again it sends that electrical impulse or charge then going over its axon. Okay, and so in here now we can talk about what are some things that we can measure with this. So your neurons are constantly firing in that way, but they fire at different rates. And it makes sense that they fire at different rates because dependent on those rates, that's how your brain is able to process and relay back different signals, right? You know, you can go to pick up a cup, and there is going to be a different frequency given in order to pick up a heavy or full mug like I have in front of me right now, as opposed to if I went at a styrofoam cup with that same amount of electrical impulse, right? And the frequency of that, and I went to pick up, I could end up in certain variations, that one, the cup might just go flying a little bit. In other variations, you can think of with like lifting things that have significant weight, you could actually hurt yourself. So of course, there's going to be differences in how those impulses take place. So one of the ways we can actually measure this, all right, is we measure the frequency of that electrical impulse being transferred down that neuron, or the message that's relayed in that way. And that occurs through something called looking for the action potential, which is polarization of the axon going constantly from positive to negative, and then goes positive to negative, and then there is a a period for it to have a recovery period where it switches and goes back the direction again. All right. And this is important to note and discuss with the students on, because this ultimately is what we are doing with our microwave sensor. Okay. So for the presentations for this unit, you actually all right. So for the presentation of this unit right here, for the presentation research, what the students are doing, you can have them work together as a group. If your groups are by tables, they are going to be assigned. And for me, I've always let my students be able to pick, because I've learned a lot over the years from them in that way, because like I won't realize that somebody does have, I've had lots of students where they've had members or people that they knew from other places who have one of these neurological diseases. And so with that, you have ALS, multiple sclerosis, Parkinson's, Huntington's, all the way through spinal muscular atrophy. I bring this one up in particular because that's actually the biomedical project I'm working on with several of my students right now, is for a lady who has type 1 spinal muscular atrophy. So that's, she's had SMA since birth in that case. So the fact that she's actually 5.5 years, well, she's more than 5.5 years old. She'll be 6 in September. So the fact that she is that old actually is quite remarkable for a young woman who born with that disorder. So they're going to go through and they're going to conduct some research and develop a set of slides to be able to share all of this information. So looking for cause, symptomology, how often it occurs within the population, other interesting facts, actually looking to see who are people that are well known, who potentially have this disorder. I also allow them, you know, just to go for those who are popular or those who are famous in that way, but they can bring in their own experiences with this. Talk about with respect to diagnosis, how is it diagnosed? What is the prognosis for people who are diagnosed with these disorders? And then also you bring in whether or not prosthetics are actually something that can be utilized or possibly could be helpful for those individuals. All right. And so that takes you through that one. Let's see. I'll just pull it back that way. All right, and so now we get into the pre-activity. This this unit here, in terms of content, is, for me, it's really more based on storytelling and trying to help the students through the process of how this all works, okay? As opposed to some of the units we had previously that, you know, are more vocabulary and vocabulary and math heavy. All right, for our pre-activity, what you're going to be doing with the students is they are going to work, you're going to show them diagrams, and then they can try to replicate of how to wire their MyAware sensor. We'll start that process by bringing them back through a discussion about how we utilize sensors to get information, right, through our 5 senses to the brain, to where the brain is then able to process that and then can send a related response. All right, and this one we're talking about a motor neuron. All right, and now we're going to incorporate the actual pieces that we'll be working with. So in this respect, your MyAware sensor, this is a picture of the first generation MyAware sensor. Those of you who have kits from Vanessa, you should have one of the MyAware sensors already in there, already in your kit. You should also in that kit have a Vex claw and motor as well. But with this, now if you went to buy this, you actually can't buy the MyAware first generation sensors anymore. Not straight from Adafruit, which is the company that makes them. They have moved on to a second generation, which I'll show you guys again. I know I talked about it briefly during our 1-day refresher call on Tuesday. But acting as our sensor, okay? So this in this acting as that sensor to be able to detect, which is then going to be sent back right to our Arduino. Our Arduino is then acting as the brain, even though as a basic microcontroller, it most definitely is not a brain, but it integrates that signal, okay? So it's going to take, process the signal, and then it's going to send an electrical impulse, right, to either open or shut your claw. And that's what's going to happen there with the Vex claw you see. All right. So this is a little bit more than of a detailed image up close of that MyAware sensor. It has 2 different electrode snaps that are actually on that red bar, and it has a 3rd one that's actually right here. That's under this, and this is your ground. Okay, so that reference cable in that way of how it's detecting that impulse of your muscle through your arm. All right, there's the power switch button back and forth over here. That's something that's actually quite good to note, because sometimes as students are moving things around and trying to get these snaps on and off, they can turn that power switch off, which of course is going to then mess with the outcome of what they're trying to accomplish. All right, for when you get these in the mail, these 3 pins right here are free. For those of you who got your kits from Vanessa, it's my understanding that those are already soldered. All right. And you'll see from there too, like there is the diagram here, and you could choose to have your students solder their wires in. That's the understanding that you really have to work with them on that difference between soldering on a breadboard as opposed to soldering wires they're more accustomed to, because it is quite easy for them to actually significantly damage the myaware sensor. So here, what you see with the plus sign is going to be typically where a red wire would come out then, power supply or power forward. You have the negative right underneath that. That's going to be your ground, which would typically be a black wire. And then you have your SIG or output signal right here as well. That is typically a different color. And a lot of the wires I end up giving my students to be able to use for stuff like this. I'll just kind of go off of a basic, I'll usually go with yellow. And that way. All right. So this is something that's very important, and it's something that you will definitely be working to play around with to get a feel for as you do this project using your own arm. So what this is looking at is a picture of that muscle that's on the other side of your forearm. And if you just put your hand on your forearm, down kind of on the underside of your forearm, down about midway is where you would start with your arm, with your other hand, and you'd let your hand rest, go in the direction of your elbow. As you make a fist, you should be able to feel that muscle underneath tighten. And then as you release it, feel it stretch and loosen again. And you would keep playing with that back and forth. And I have the kids do that back and forth to play with it to really get a sense of, all right, now we feel it tighten. Now let's try to get a good feel for where on your arm does it tighten the most, where it kind of feels like there's, you know, a little something in there. You can definitely tell that that's like the piece that's moving back and forth. That is where you're going to want to place your myaware sensor. And you notice here too, it's showing for your myaware sensor that you are placing it parallel. Okay. Or another way you could see is like it's vertical. Okay. To this plane, which would be your arm. Okay, so if my arm, I look at it in terms of like a Cartesian plane, or for my students, we talk about different planes and stuff like that all the time because of working on CADs. But you really want that myaware to go up and down in a vertical fashion. All right, so that's the one that's in green. It's showing correct placement. It's going to get the best signal. This can cause a problem. You know, if we're not exactly in that spot, your signal is not going to be as strong. And so then later on, when you're trying to get it to program to open and close your claw, there'll be a difficulty in getting the right reading. And so we do move them around a bit. And here, what you're doing is talking about what does the myaware sensor actually detect. You're going to have some students that are very nervous. Here we've talked about electrical impulses and stuff like that. Even though it is the arm, the muscle that is doing the electrical impulse, you'll have some students that more so look at that myaware sensor as something that's going to cause an electrical. And so there's concern on their part, like, how does it actually work? What does it actually read? Is it going to do anything to me when I put it on my arm? There's lots of interesting theories and other stuff out there that of things that can be implanted and stuff done to the body that, of course, your students are going to have been exposed to. And so you have to have those conversations about what this is and what's going to happen. All right. And so what it's doing is actually it detects, it pulls in that the electrical impulse, basically, EMG of that's going through your muscle. So it shows here with a raw EMG. And this one that we're working with here is actually a rectified version of that. Okay. Here, this is a diagram of how the students are going to need to wire their eyewear sensor to their Arduino. So it's going to need to go into the 5-volt pin. Yes, it does make a difference, 3.3 as opposed to the 5-volt. It will need to go into ground. And of course, it doesn't just have to go into this pin for ground. It can go into the ground across from if it needs to. And for purposes of our initial programming work, we have it going into that first analog pin A0. Okay. Now, can they change it to another analog pin as they're going through, especially if there's something wrong with their Arduino, or they're trying to decipher what could possibly be wrong? Yes, definitely. It just has to be changed in programming. Okay, so the only reason why for this purpose, like I have my students do this initially to where it is in A0, is just for ease of programming, for ease in us discussing the program. All right, and so as it's been done, now I have the pre-activity, which there's the pre-activity up there for the students to have, and we can go through and start talking about the programming. Okay, and so in this one, this is just that basic refresher or review for the students. It is placed in here really to give you guys a little bit more freedom sometimes in maybe how you do your presentations. The most I've done is biomedical engineering has always been my very last minute, but it was second to last one time. So I switched, and I had a senior who was in my class, and she was very much into, and actually has gone on to major in biomedical engineering. And I wanted to make sure we could cover that with her, just in case testing and other stuff got in the way. And so I switched and put biomedical engineering in front of environmental. And so then, in that respect, I really didn't have to go through this that much because I just finished chemical engineering, chemical petrol. And so my students already had gone through and they had programmed their DHT sensor to be able to register the temperature of their Cajun air conditioners. All right. So in that respect, right here, that's just how to gauge whether or not to use some of these slides. Okay, and here's a slide in here again to help you talk with students about how to use comments, the importance of commenting. This is a little bit more of a complex program, so it is more important to help them, to whereas they're trying to work together to troubleshoot a code, having those comments out of the side, which is basically your pseudocode, so to speak, is helpful for them. All right, so the piece of this that you're getting into, this is just taking through and talking about that same thing of turning your LED on and off and what it's going to look like. So again, I'm not going to go through just all this with you guys because this, of course, is stuff that we've already had been talking about all the way through. Some of these are slides that are coming in from Intro to Engineering as well. but bringing in with respect to your tables. Okay, but you do want to bring in, let me bring this back. So here with this one, we have to look at how we do have to declare our initial global variables that we're going to be using for our program. And so here we have that the onboard LED is going to turn on, and that's in pin 3. Your onboard LED is actually a light that, an LED light that's actually on your LED, on your Arduino. And what's nice about this is there's a lot of complexity going on with what you're trying to do for this to make this project work. And so sometimes the issue could be, as you're trying to do this, that maybe it's your Arduino that's having a problem. So that's something put into that program early on that can help you then kind of think back through or what the problem could be. You see here the MyAware sensor is put into, or is declared as being in pin A0. And our voltage threshold. So this is something that, of course, is later on used within the program. We are going to be reading our MyAware sensor. That reading is going to have to be given a name, which it will. But then also in that we have to set what is going to be the reading that we say, okay, if your impulse is over this particular reading, then we want an action to take place. And that action is we want our claw to close. If the signal, EMG signal being read, is below that threshold, similarly, we want an action to take place. In this case, we want your servo motor to turn in the opposite direction and for your claw to open. And this right here, the voltage threshold of 400 is supposed to be the average in terms of, on average, once you hit that 400 threshold, it signifies that your fist is closed, and so then we need to clear our arm. I have found a real discrepancy. I personally have a neurological disorder, which runs over it. I basically, for my disorder, my nerves are constantly firing in various ways, and so I tend to I have a much higher threshold as a result of this, and I every once in a while have another student that will be the case for. I've also found that with our student athletes, a lot of times this voltage threshold here is actually significantly lower than 400. So it's kind of a neat thing to see. You'll see for yourself as you go to do this project over the next day or so. You'll pick out and figure out what your threshold is. But for right now, we're just going to say 400 within our program. Okay, and so the pseudocode for this is basically here we're going to read our sensor value. And then we're going to have to get into a function, all right? First, we have to decide, is current, this sensor, is the current that comes in, is that voltage greater than our voltage threshold that we set? If it's not, okay, then the muscle isn't contracting, so it's going to stay put. All right, or open back to a position that is needed for that. If it is higher than that threshold, then your muscle is contracting. And so in that respect, right, for this one, because this is our pre-activity, we're going to be telling our serial monitor to print. Here is our function. Is it greater than threshold? If it's not, then the Arduino will have the serial monitor print at rest, okay? And the onboard LED light will be off. If your serial monitor, if that current that comes through is higher than the threshold you set, then the serial monitor will be told to print contraction, and the onboard LED light will turn on. So you can see the importance of that in trying to figure out, sometimes, like I said, what's going on. Having that light turn on and off is also helping you as well, because then maybe the light's turning on and off, but the serial monitor is coming up exactly the way you wanted it to. That's telling you, okay, let me go back and look at my code that I put in for the serial monitor. So it's a way to help you troubleshoot. Okay, again, this is bringing in that same slide as before. For your if statements, I typically just go back over into this slide and I have the students start to talk through. All right, what are we trying to write here? If the voltage threshold is, all right, if it's greater than or equal to something, we want our claw to close, right? So let's talk about what this is going to look like. The first thing we're going to have to do to even get to the point where we can have a voltage threshold, right? So we can start dealing with our conditional statement. We have to be able to read, right? So we have to know. And I know this is how we know the button is pressed in this one. That's just bringing it back to, remember in intro, when we were working to talk about when you press the button, then your lights turn on, okay? So this is also bringing in that respect to, this is how we would do it. So we initiated the button state, and that was the digital read where we were reading the push button. And then we put in our condition. So like if that was true, so if it was high, then we wanted the light to turn on for so many seconds. All right. So here we're bringing in again, you have this slide again in here to help you with the comparisons for these different operations. You can bring them back to this one. I tend to just go straight into, for each of these slides, we're bringing up that, I tend to go straight into, let's just talk about the program that we're working on right here. But with your students, you might find that going back through what had previously been covered and maybe seeing what they can pull up or what they can remember from this. And then, of course, allowing them a lot more autonomy. All right. So again, while this is dictated towards how this would go in for the push button, let me go ahead. Oh, that's not the one I want. Oh, let me do activity. Okay, so this is the pre-activity one here. It again is showing them where it needs to be brought in, or how to wire it in that respect. Okay. So you're working with them on that same flow chart like what we had in the slides. And then here is a little bit of help then getting them ready for how they're going to make this part work. Let me do this according to so it's not just me talking blindly. It's not in there right now. I'll make sure, for some reason, it's not in here to where it shows like the pre-activity solution, so that it's not just me talking about the solution. There's benefit, of course, to being able to see what I'm talking about as well. All right, this is actually here. This is a sample code, a solution code for doing the entire project. All right, for what we're doing with the MyAware sensor and stuff like that to begin with. You're going to be doing this where like these portions right here, you will not need. Okay, so here you can see for that initial one that you're doing with your students, your variables are going to include the position of where the MyAware is, which we have here is A0, your onboard LED being declared, and your voltage threshold. Now that is that you essentially are going to go back and change a number on. So that is definitely something, depending on the readings you get from the MyAware sensor while you're using it, you're going to have to change that part. Okay, so into our void setup, we of course have certain things that we need to declare. So I'm declaring, well, first off, I'm turning on my serial monitor, which you see here, the serial dot begin. You have here that we have to declare, of course, the pin mode for the onboard LED, and it is, of course, an output. The VEX motor part, if that's what you're using, that's not part of your pre-activity, but you're also, you have to declare your pin mode, you have to declare the MyAware sensor, and in that respect that it is an input. All right, these two, the
question, please.
Sure.
Yeah, just looking at this code, this looks almost exactly like what was on the slides that you would be going over with the students. So if they were crafty, couldn't they more or less copy all of that and just change the values as needed?
Yeah. A part of that is as you're going into it, I mean, it's in there based on, you're going to decide how much of that, how much guidance your students are going to need. So for me, usually like I'll go in and talk about it. I've had some to where I have to almost give them the entire code with certain things that they change just because of a struggle that they are having with it. But the majority of time, especially at this point, and that's kind of part of what you do as you become more adept at this. Like All right, here's a new part that I have. I'll go look up and see this part and see a sample program. I'll include the program, and then from there tweak it. And then now I have to take it a little bit further and do with that do with that program what I want. So I don't give them this entire code here at all. That sample program that I give them is the initial one for the pre-activity. So like for my students, we go through and I am explaining it to them and talking them through the logic behind the program for the pre-activity, just to get your MyAware sensor to turn on and so that they can start reading their serial monitor, and then starting to get some data from that as to where their voltage threshold is, or whether or not we have to move the MyAware sensor because it didn't quite place it in the right spot. But then from there, at this point, they're working out the conditional statement to make it work. And for me, like here, it's like I'm pointing out to you guys for the VEX motor. This is the program if you're doing a VEX motor. I don't ever use VEX motors because I don't use VEX. I have a couple of the VEX claws and stuff like that as well, but my students actually use micro servos, and they create their own claws. All right, so they have to go in and figure out how to make that work. But with this one here is the continuation of that, of reading the MyAware, assigning that, reading that value, a name, which is going to be current voltage here, and whether or not that current voltage, so our condition is whether or not the current voltage is either greater than or less than the voltage threshold. All right, and so that then through here. But I do provide the initial portion for them. I just wanted to be able to share that out with y'all on that part. All right, how about we take a short break until 2:30, and then we'll get back on real quick after that, and I just have a couple final things to share about the project then. All right, so you'll hear my voice again then at 2:30. All right, so I don't have too much more to work on with y'all, just to help you really for us and being finished for today. I did want to show you a couple of examples. So again, you can do this utilizing the Vex Claw in that respect, and some may have them. For me, I did not have the Vex claws. I don't use Vex in my program with my students here at Hammond High. So I actually do this utilizing micro servo, because typically most Arduino kits do come with that micro servo. Plus, when I initially did this course, I didn't have access to a Vex claw, and so I also had to make my own. And so I have a couple of examples. Actually, these are all examples of ones that my students made this year. So it was neat. I like doing it because it's neat for me to get to see from the students' perspective how they're going through and thinking through what it is actually that kind of function of a hand. So what they have to do is pick up, for me, they pick up a water bottle. The water bottle is empty initially. And so to be successful, they just have to pick up the water bottle by closing their fist. And then they have to release the water bottle by opening their fist, right? It's showing a success with the project. And then for an additional measure of complexity and fun for the student, then we'll say, okay, so now I have a water bottle, and it's just a standard small water bottle that has water in it. So in that respect, now it's got some weight to it. And also with that too, if you're picking up a water bottle that's empty, its shape can change more readily than it has water in it. And so their designs then are going to reflect some of that. So usually I do get a lot of these where it is this part where they, let me get this one correctly. There we go. Since of course these aren't wired, so I'm just having to move them, and I don't want to break them. So this, usually it's one that's stationary on one side, and then they have it to where it turns and brings in their claw that way. This group actually put an added string in here as well. And that was done because they didn't want for there to be a continuation or a stress back on the servo. All right. Others, let's see, I had two that were really cool this year that I've never designed before. Whoops, of course, this just fell off, but they have it to where it doesn't impact the servo. So this is with a straw. It's wrapped actually all the way around. So the only thing this thing is good for is picking up something that is a little bit smaller than that shape, but of course the water bottle would be. And so as the servo turns, then the string is pulled tighter. Okay, and the string pulled tighter, it wraps then and closes then around the bottle. And then when it lets go, there is a and this back it opens back again. And you can put different things in here to serve for a grip. This one actually looks a lot like a hand. You can tell right here that cup They put foam on the inside along with some ribs of hot glue. And I really like the thumb because it looks just like a thumb that you have right there. And they did put a bit of a grip on the inside of them, which is a part of a popsicle stick or a craft stick that has some glue over it. And so they take it and as it turns, it grasps in, which is exactly the way your thumb moves right here. They did have, although it popped off a couple days ago, so we just had to put it back on. And it is all with hot glue, so it's easy to do. But they also had a rubber band on here as well to be a tensioner to help in reopening. Okay. And then being able to do it that way. All right. And this one is the first time I've ever had one that looked like this. And they actually did it. They have it constructed in here that as it turns, oh, this one's come up off as well. As it turned on the servo, then it opened, and then as it closed back on the servo, it closed and clamped shut. And again, that's looking at it like this, which is pretty cool. They did this all. This is one of my all girls groups. And they also put cut pieces of rubber band on the end to assist and act for grip. All right, so that's a couple of examples. Because otherwise, you know, again, you're looking at how you can help your students as they're working on this within their project. It's a way for me that I have some students who within a group are working on the program and the configuration of how to put the, utilize the malware. But depending on how big your group are, you know, what are the other students in that group going to be working on as well. And so in this case, by having them work on creating their own claws, that really solves a lot for me. It also adds that element of creativity because a Vex claw comes put together because that's Vex. And that way. All right. What you guys have for that you are responsible for this training here for the summer is you will need to go through and complete the project end of the using the malware sensor and making a claw to open and close. All right. With each of the pieces on here too, you should also have, those of you who got your kits from Vanessa, you should also have hopefully some these like 3M connectors because you will need something that those things can snap onto you. So you see they come off like this. And this is how I get mine. You can take on. All right, you snap on that way and then peel off. And you see how you would take and place them on your arm in that fashion. If you, I order mine usually about midway through the year. I have a little money so that I don't have to worry about it towards the end of the year. I order mine in bulk for my students. When I actually did this project, when I was becoming certified to teach it, I didn't have any of these and I had no way to be able to get them real quick because we had to turn and do our project for the next day. So I just went to Walgreens and I actually found some of this just electrode snaps that are used for like heart monitors and stuff. And then I just cut it to fit my arm. So it was way bigger than what I needed for my arm, but I just for the purpose of doing this for this project, for the summer training, I went on ahead and did that. So if you run into any difficulties as you're doing the project, especially with those, just reach out to me and let me know it, and I can give you some suggestions on other stuff to use. And again, this is what the the MyAware 2.0 looks like. Different, of course, from the first generation one right here. So everything I've done with it, I've been able to take and program, and it does the same. So there's not a variation that way when you have to get them. Okay. So you'll make sure to take pictures, and it's noted in the assignment for you as well as to what to do. You also have the homework paper to complete, and again, and then of course the quiz. All right. Are there any questions about what's expected? Okay, then. Well, I'm going to go on ahead and then just mute myself. I'll stay on, as always, until 5 in case anybody wants to jump back on with a specific question, want to need to show me something, or have a question. Otherwise, hope you guys have a great weekend.